everybody. We have had some issues this evening, so just let me get a couple of things straightened up. There we go. Right, so we have had to start streaming through Facebook because Khaled wasn't able to do his presentation through, speak through Skype. So we've last minute bodge job, and hopefully you're going to be able to hear these guys, so I'm going to take them off mute now. Are you guys both there? Brian and Crowexe.
Crowexe is here.
Crowexe there. Cool. Could you just speak a little louder into your mic as well, if that's okay, so we can hear you a little bit better?
Yes, okay.
Perfect, right. And Brian, are you there?
Maybe he muted himself.
Brian, maybe you've muted yourself, Brian. You might need to take yourself off mute there. But
hello, can you hear me?
Yeah, I can hear you now. Perfect.
Yeah. Sorry, my computer it's freezing up with so many things open. If it's freezing up, I couldn't turn off the mute button.
No worries, no worries. Listen, I appreciate you guys for working around this and being able to get the show on the road this evening. I know it's been a bit of a struggle. I mean, trying to figure this out. I mean, even Google Hangouts isn't working anymore. They've stopped doing that, so that's something that's happened very recently. So we weren't even able to do it through that. So we've got it on the road, though. That's the main thing. And essentially, we're going to get into this Analemma debate, because you've both done a presentation. Crow, you've done yours from the globe side, and Brian, you've done yours from the flat earth perspective. So you've both had time to look at each other's questions. You received those questions yesterday, is that right?
Yeah.
Cool. And you're happy with the questions? You think you can answer all the questions?
Yeah.
Okay.
Yes.
Right, well, I'm thinking of doing something a little bit different tonight as well, which is, obviously this show is going to adapt. We're going to see some changes happen over the time that it's going. What I've noticed is that some of the times when people are asking questions, the questions aren't fully getting answered, and I feel that it's like a stalling tactic or a tactic to detract from the actual question. So it might be that they're trying to in some way obfuscate the point, so that the point gets lost and then the question gets lost, and then we don't actually get any resolution to the question. So is it alright with you guys if I allow you to try and gain a moral victory by allowing some kind of objections to be raised if you ask one of your questions and you find that the opponent is stalling on the question or not answering it or skirting the issue in some way? You can object to that, and we'll sort of like award a point or so if you think that the objection's upheld. It's just a way to try and sort of like create a little bit of meaning to the debates at the minute, because if we lose that whole point about this debate, which is to try and find a resolution, we're never, and we just bring people in and they just try the same tactics over and over again, we're never going to get anything. But if they think there's a moral victory to be had, it will encourage people to answer the questions as best as they can, because they won't want to lose a point. Does that make sense?
Yeah, that makes sense. Yeah. And that for the audience, because they want to see at the end, they want to be able to see whether they side with one or the other or whichever.
Now, obviously, I'm not perfect at this, and it's highly likely that anything I do is going to be very controversial. So it's like I'll probably award a point where it's not merited or something like this. And I'm only human at the end of the day. I can only view it from my own standpoint and how I feel things are going. So, it's like if Crow asks you a question, Brian, and you skirt the issue or you don't know it or something like that, and Crow says, "I object to this because he should know this." Then I'm gonna side with Crow there, and I'm gonna give him a point and say, look, is that okay? Is that okay with you, Crow?
Yeah, that's okay.
Okay, so but don't forget though. I mean, I can't make the objections for you. If you need to put your hand up and say, I object to this. I object. I don't believe that this is right. He's avoiding my question here. And then we'll give you a chance to try and answer it. And if you're still avoiding the question, then I'll award a point. Is that okay? And it's not really an indication of who's got the better argument. It's just a kind of a moral victory at the end of the presentation / debate. Yeah.
Yeah.
Yeah. Who gave the most in the debate, as opposed to who has the right facts or the wrong facts, kind of thing.
Yeah. I mean, there's no win or lose here. It's just a personal thing between you two. So as long as you answer the questions as best you can and you don't try avoiding it, nobody can pick a point from you, because you're just being as honest and open as you can be. And that's what I want this platform to be: very honest, very open, just truthful, honest answers. You know, I don't want to go into this tactic of trying to avoid stuff. I want answers. I want you to answer as best you can. So, without further ado, who wants to go first, or shall I flick a coin for it?
I'll leave Crowexe go first if you want. With the first question.
Or would you prefer first or second, Crow?
That's okay. I'm fine. I have no say today. I did enough damage with the Skype issue, so okay, I'll go first.
Okay.
No worries.
Okay,
Right.
So I start now.
Yep. Away you go.
Yeah. So I was supposed to post 5 questions, but they are 6. But the first 3 questions, they are actually just wanna know stuff, just to be on the same page. So the first question: can you list?
Just before you start, Crow, just to tell you, what I did was, because you had 2 questions for number 2, is I left the last question until the very end. But like, I took the second number 2, what's the equation of time? I put that at the very end. I didn't know if you were still going to answer that, or I didn't know if that was a typo or something when you put 2 there. But if you want, I'll answer it with the number 2. If not, we can answer it at the end. There's no big deal.
The question about the equation of time, I can answer this question. It's just to be on the same page.
That's no hassles. Yeah. Okay, let's far away then.
So the first question: can you list some of the factors that affects the air temperature in a certain region?
Okay. With this one, what it is, I wrote out all my answers, and you can debate with me after that. For this one, my answer is pretty straightforward. It's not a very long answer. Some of the answers are long, some of them are short. For this one, I just gave very basic answers. The air temperature is affected by the seasons, by weather patterns, elevation, and the night-to-day balance. That was my answer to that one. If you want, I'll repeat that.
I'd like some. Maybe my question is not clear. The air gets hot because of what?
Well, if you're wondering, if you're talking about the pressure, you're going into the realms of pressure, air pressure. Because the air temperature rises because of an interaction with the sun.
Yes.
Yeah. So that's what my answer was, very general. If you want the air pressure, are you talking about pressure, like higher pressure and lower pressure, or just temperature?
No, just temperature.
Well, it's the air molecules interacting with the sun causes warm air, or hot air. It causes air molecules to expand and to rise. Is that a better answer?
Yes, that's very close. That the radiation from the sun heats the air, and the air goes through convection. So those are 2 methods of transferring heat: radiation and convection. But the main one is conduction. That's the main thing that heats up the air.
Okay, so at this point I would normally give you guys a 5-minute chit chat with each other about this subject, but is there any point, or is there a leading point to this question? Is there something that you actually want to address further than this, or was that essentially it? Okay, well, I'll let you guys get into it for a little bit then. If you want to do, I'll give you 5 minutes on this. So away you go.
Okay. So.
massive. So I cannot give you a straight debunk that or refute that the distance should do that effect that you expect. But there's a lot of things that I found by accident. Like, for example, the first minutes, maybe half an hour after sunrise, you still see the reflection of the sun on the water. That means the water is not absorbing the heat; it's reflecting it.
Yes.
Guys, can I just say that my OBS seemed to mess up there for a second, and we didn't have any audio playing through. Is it possible to start this 5-minute countdown again, and you guys get back into this again, because the audience will miss this point?
We can go through the points back to where we are, where the reflection is on the sea.
Yeah. Okay. So we'll start again. Sorry to the audience. Sorry to you guys. Yeah. Carry on again. Sorry.
Yeah, it's okay.
Do you want to fill in the audience, Crow?
Say again.
Do you want to fill in the audience on what they would have missed?
Yes. Okay. So when I say that the air gets warm by conduction, you pointed out that maybe I'm referring to why there's more land in the north, and I say that's only a factor, but not the main factor.
Yeah.
The water would reflect the sunlight in the early hours of the morning and the last hours, and that's how we see reflection on the water when you're standing by the sea or by the ocean.
Yes.
Reflection means the water is not getting warm.
Yes.
But after that, the sun is high and can warm up the water, but it goes deep into the water, and we don't know the layers or the currents of the oceans. Where does it take this heat? Does it take it up to the North Pole, or does it take that heat down to the South Pole? So these are a lot of issues that has to be studied.
Well, what I would say about that is, I understand what you're saying. I understand your argument concerning Antarctica and it's not melting like the Arctic does, even though on the Earth model it's heading for 5 million kilometers closer to it. On the flat Earth model, it absolutely makes total sense why it is not all melting. As the sun on the flat Earth model, if you're talking about the southern summer, the sun on the flat Earth model is low in the sky. So what it does is it melts the ice sheets that have built up in the ocean, and it melts around the coastline of Antarctica, but it doesn't melt the main ice shelf. So the flat Earth Analemma, I won't say model, the flat Earth model. I won't say globe model or flat Earth model. I'll just say explanation. The flat Earth explanation of the southern summer portion of the Analemma has the sun low in the sky, moving on a bigger loop around the Tropic of Capricorn, but moving faster. So what it does is it melts the ice that has built up in the ocean or through the winter, and it melts back basically on the coastline of the Antarctica. But it doesn't affect the top ice shelf as much. And it's more, the flat Earth explanation is that it actually protects the Arctic from becoming melted either too much or too much in the wrong way. So that would be my argument against that, if you know what I mean.
Okay, there's also one argument.
Okay.
The sun is, or the Earth is closer to the sun during winter, but it is faster. Do you agree?
In the summer, during the southern summer, in the globe explanation, the Earth is in the sun. Are you talking about the flat Earth or globe Earth explanation?
No, about the globe Earth. It is closer during winter, but it is faster. Is that
during the northern hemisphere winter?
During yes,
yes,
during the
during the northern hemisphere winter, yes, it is. The sun is closer, and supposedly the Earth orbits the sun faster.
So
yes, I agree with that totally. Yeah.
So
sorry, I just have to make sure we are on the right page. Yes.
Yes.
Yeah.
So this is also another argument that yes, you are closer, but you're spending less time in that close area.
Yes, but it's the closer element is the problem, because if you move the Earth closer to the Sun by 100 miles, would it have an effect on the Earth? Because I've read online some stuff about the question, if Earth was closer by 1 inch to the Sun, would it have an effect on the Earth? And some people say it would. It's the closer element is the problem. To be that much closer is a lot.
You mean the more effective element?
Yeah, well, I couldn't see how we wouldn't have an. Now, we do supposedly have 7% more sun intensity during in the southern hemisphere due to the closer sun.
That's your 5 minutes up on that one, I'm afraid. So
okay.
Brian, would you like to ask your first question, please?
Yeah, 1 second now. I just get it up there. Okay, my first question is, okay, Crow.
Yeah.
How on the globe explanation of the Analemma can I see the sun from 5 o'clock in the morning until 10:30 at night on the 21st of June without a change in rotation speed of the globe? I'm at 52 degrees latitude north. If you want, I'll repeat it.
Yes, okay, I got it. Rent, can you present a picture of those I sent you? It's called Day.
Which one would you like, sorry?
Daylight.
Okay, 1 second.
So basically the Earth is, or the axis of the Earth is tilted. I don't like to use the expression that the Earth is tilted because it's a ball, so it doesn't have, the axis is tilted. And that means that the upper portion that is towards the sun receives more light, more light time.
23.5 degree tilt, that one, yes.
Yeah, so the equator usually, or not usually, always receives half a day, or to be exactly between 12 hours 6 minutes and 12 hours 8 minutes of sunlight throughout the year. And the rest of the globe, it can be compared.
Can I just ask Brian if you can actually see this image on the watch page?
I'm looking at it, yeah, because I'm looking at the watch page on my phone, and then the rest on my computer. Okay, just because there's still many things open, my computer is there. Right, yeah, I'm looking at it there. It's an Earth with the equator, and I can see where there is what I think is supposed to be sun hitting it up at the top right hand corner.
No, that's just the compass of Google Earth. But do you see the red dots on the globe?
I do, yes. Yeah.
Okay, so the first dot on the equator represents the sunrise on the equator, or and on Greenwich mean line. Yeah. And if you go to latitude that's probably 23 or the Tropic of Cancer, you see another dot. So
yes.
by the time there is sunrise on the equator of Greenwich, on the 23rd, there's been already 40 minutes of sunlight, and if you go higher, there's more time before that point. If you are on Greenwich, you are presuming, or you're supposing that the globe should have 12 hours exactly as any point on your same meridian. But with that tilt, when sunrise happens on a certain point on your same meridian, you've already had 2 or 3 hours of sunlight before that moment.
So Brian, does that answer your question?
That is the I have no problem with that answer. That is the answer I expected.
Okay. Do you want to get into a debate for 5 minutes on this? Or
yeah, we'll do 5 minutes on it. Yeah.
Okay.
Yeah. Okay. So, Crow, see, my issue with it would be that from 5 o'clock in the morning on the 21st of December until 10:30 at night, I can actually see the sun all the time during that time. Now, I can't see on the globe model, including the tilt, and the fact that the sun is going over the Tropic of Cancer, I can't see how I could see the sun for all that time and only have a 4-hour night, more or less, after that. Well, it'd be a bit more than 4, only a few hours. It'd be half 11, half 12, half 1, half 2, 3. You'd be talking a 6-hour night after that. I can't see on the globe model how the rotation speed does not have to change, as literally the next day is nearly a carbon copy. The 22nd of June is nearly a carbon copy of the 21st. It's almost a carbon copy, not exactly, but almost a carbon copy. So I don't see how, without a rotation speed change, how that is possible for me to be able to see the sun all that length of time. From half 5 is half 6, half 7, half 8, half 9, half 10, 11, half 12. So if you're talking 15 hours, about 15 hours of sunlight when the sun is over the horizon. And you can add more in because it actually comes up about half 4 and doesn't go down until about 11:15. You can add 16 plus hours of sunlight. But for that, when I can see it fully over the horizon, it's 5 in the morning until 10:30 at night. So it's 15 and a half hours of sunlight there, where the sun is over the horizon. And I just cannot see if this rotation speed stays the same. I do not see, and at my latitude, the rotation speed I think is 740 miles an hour, or is it 800? Somewhere between 700 and 800 miles an hour. But I just don't see, unless there's a change of rotation speed, how I'll be able to see that sun all that length of time. The flat out explanation of the Analemma explains it. But I'll leave you answer there. I'm not going to say anything.
So the dispute is the I'm saying, so your objection is
my objection, just to clear it up,
time, but not that there's extra time. You agree? Say again.
Yeah, my objection is the rotation speed. My objection, just to shorten it down, my objection is that the rotation speed would have to change for me to be able to have that long of a day and that short of a night. That would be my objection. That the rotation speed would have to change.
Just to say that you've used nearly 3 minutes of your 5-minute time just explaining a question. If you want to answer to that, Crow.
Yeah. So as I'm showing this globe model, it's showing the latitude line below England. I'm not sure what is that, but it have extra 3 longitude lines. So each one of them is 40 minutes, and if you go higher, then you add more. So until that longitude line, I cannot see more clear than higher than this. But that is maybe 2 hours and a half. 40 each line is 40 minutes, so multiply that by 3. Yeah. So until that longitude line, you see those 4 dots. On that latitude line, you have like 2.5 hours or 2 hours. So if you go up or if you go higher, then you get more light until you are on the North Pole or the Arctic Circle. You get the full 24 hours.
Yes, but that's the thing. You see, for me, I have to actually be able to see the full sun, on which I can from 5 in the morning until 10:30 at night. That's 15 and a half hours. I can see the sun fully in the sky for 15 and a half hours. Whereas if the globe is rotating, I shouldn't, at the same speed all the time, then I shouldn't be able to see the sun that length of time on the globe model. That's my qualm with it. I don't see how I can see the sun for that length of time. I don't see how it's possible without the rotation speed changing during the day.
By daylight, I mean the sun is above the horizon.
Yeah.
So at that latitude, you have 2.5 hours extra than your brother on the equator.
Yes, I understand that. Yeah. I understand the mechanics of it. But for me, the point I'm making is for me to see the sun.
Okay, your time's up there, guys.
Okay, all right.
Okay.
Oh, it's all based around the same thing, so we'll be back and forward on that. Go on. So,
No worries, no worries.
okay.
Right, so Crowexe, do you want to ask your next question? Question 2, please.
Yes. What is the solar day and sidereal day, and how are they interpreted or perceived by flat Earth?
Okay, I'll just get out my answers here. As I said, some of the answers are a bit longer and some of the answers are shorter. So what I'll try to do is speak slow so you can take in the answer.
Yes, okay.
Okay, the solar day is a full 24 hours, whereas the sidereal day is 23 hours, 56 minutes and 4 seconds, leaving a deficit of 3 minutes and 56 seconds between the solar and sidereal day. The sidereal day is based on astronomy and is connected to the sky as opposed to the sun, connecting to the position of a distant star as opposed to our closer sun. The solar day is based on the sun, and it's what the yearly calendar is based on, and the solar year is slightly more than 365 days. It is 365.2422 days, so almost a quarter of a day more, which gives us our leap day on the 29th of February every 4 years. As for their perception on flat Earth, the sidereal day is more based on globe Earth rotation and is actually slightly shorter than a stellar day by 0.0084 seconds. It is a time scale of the supposed rotation of Earth in relation to the sky's fixed stars. The difference on the flat Earth as far as the sidereal day goes is everything would just be based off what the sky is doing and timed only with that. No rotation or movement of the ground is added in. So consequently, whatever the sky is doing will be all that would matter on the flat Earth. As for the solar day, the sun gives us our day, the moon gives us our month, the seasons then give us our year. So it would not be perceived much different other than maybe a change in the type of calendar over time, but that may not happen also. So the only difference would be with the sidereal day. The solar day is still going to be the solar day. As I said, the sidereal day is more based off of the rotation and the rotation of the Earth in connection with fixed stars in the sky. That's my answer.
Okay, so yeah,
Sorry, was that a suitable answer to your question?
Almost yes. I just want to confirm that the sidereal day on a flat Earth is the time that takes the dome or the stars to complete one circle, and the solar day is the time that takes the sun to complete one circle.
Yes.
Okay.
Yeah.
Okay.
Yeah. Well, it would work pretty much the same as on both. Just the difference is that rotation is brought into the sidereal day for the globe mod.
Do you guys want to get into this for 5 minutes?
Well, yeah.
I'm
If
good.
Crow wants to say something beforehand, we'll give it to him.
No, I'm good. If you like to elaborate on any points you see necessary, then okay.
I think with the sidereal day, it's something that I wouldn't say. Well, I don't really know what else to say about it. The sidereal day is more something that I would say, just for reference, I would say back in the time when people more in general believed in the flat Earth, that the solar day was, I wouldn't say the more important day, but they wouldn't have. Look, I'm not going to say anything about it because I'm talking about stuff that may or may not have been, so we'll carry on. Because otherwise I'm going to be saying stuff that I can't actually say for certain is definite. So.
Yes, okay. Yeah. So we can...
Yeah. Do you want to move on to the second part of your question, of part 2 of 2?
Yeah.
Yeah.
Okay. It's a good chance to.
Yeah.
The equation of time.
Yeah.
Now there's something that's called the solar day. There's mean solar day, because every solar day is not like the one before it or like the one after it in terms of length.
Mm-hmm.
So
that's right, yeah.
the average solar day is 24 hours.
Yes.
Now there's also something called the mean solar noon, which is like, for example, if sometimes at the year your solar noon is 11:30 and some other times it's 12:30, then the mean solar noon is at the middle, is 12. Now,
Yes.
equation of time is how much the day or the solar noon shifts to be longer or shorter.
Yes, the apparent solar time is got to do with the shadows, and that's more of the true solar time. And the main solar time is a more uniform solar time used for clocks, basically, and timing. Is that would you be in alignment with that?
No, what I'm exactly interested in is that when you look at the Analemma, the horizontal axis, you find it's measured in minutes or degrees. And of course, minutes can be translated to degrees by multiplying 4. So you find it maximum like 4 minutes to the right and 4 minutes to the left. That equates to around 12 minutes right and left. And that means if you come in the mean in the time of the mean solar day, and you put the shadow, you find the shadow is deflecting to the right or to the left by a maximum of 4 degrees right, 4 degrees left. So the sun, after maybe 100 days from that first measurement, it is shifted by 4 degrees or 3 degrees.
Yeah. Yeah, well, I mean, I have no argument with that. I mean, that would work the same on flat Earth, as it would. The flat Earth explanation of the Analemma would explain that the same way as it would happen on the globe.
Okay, I'm going to give you 5 minutes here. Okay, away you go.
What I mean is that whatever the sun does in the sky, I couldn't argue with that at all. The sun is going to do what it's going to do, and it'd be pointless arguing with it because it is a definite. You know, that it's proven daily and yearly. So I agree with that. What you're saying, yes, that there's going to be the apparent solar time, which is going to differentiate between the mean solar time, which is the mean solar time is the uniform time. Like 12 o'clock is the mean solar noon. The apparent solar noon can be, as you said, 4 degrees to the right or to the left of that.
Yes, and those 4 degrees they come through accumulation of the day is increasing by few seconds. Every day has extra length of few seconds than the day before it.
Or lessened. It can be lessened.
Yes, it increase or decrease. So and that on the flat Earth would means that on a certain latitude, the Earth, the Sun should increase or decrease its speed. I'm not talking about it when it moves to the Cancer or to.
You're talking about speed. You're talking about moving faster or slower. Yes.
Yeah. So it takes 24 hours on the Tropic of Cancer, supposedly, and 24 hours on Capricorn.
You see, for that, sorry, I'll leave you finish. Sorry, I'm cutting in.
Yeah. So the process of slowing down and speeding up, I cannot find a reason for it on the flat Earth for explanation.
Well, I'm going to ask you a question then, right? Where does all the data for the solar Analemma come from? Throughout the centuries, where has it come from?
Can you make that a little bit?
Well, I'll answer it rather than trying to ask you a question about it.
Yeah, okay.
All the data for the solar Analemma, regardless of whether you believe you're on a flat Earth or a globe Earth, all the data comes from watching the sun. Because you watch the sun throughout the sky. Now, in the globe model, the Earth is moving slower in the aphelion period and faster in perihelion period. That comes from the sun moving faster and slower in the sky. The sun moves a little bit faster in the sky in the southern summer and a bit slower in the sky in the northern summer. And if your model of the globe, I won't call it model, the globe explanation fits that, as opposed to the flat Earth explanation is the sun that's doing this. The sun is speeding up and slowing down. Whereas the globe explanation is that the Earth is speeding up and slowing down. But all those both explanations come from watching what the sun is doing. So the globe If the sun is not speeding up and slowing down, then both explanations are wrong, if you understand what I mean. Because the globe Earth explanation can't have the Earth moving faster at one time and slower at another, because that comes from watching the sun move faster across the sky in the southern summer and slower in the northern summer. Okay, that's where that comes from. If you understand what I mean.
I have to make correction on the globe side also, because I've seen a lot of globers. They say the same thing you're saying. If the orbit of the Earth was a perfect circle, we would still have an analemma that looks like a figure of 8, a perfect figure of 8. Mm-hmm. If I calculated how the analemma would look like without axial tilt, it would look like an egg. An egg with a little bit of tilt. That's the result of the orbit. And if you take the orbit eccentricity and consider it as a circle, it will make a perfect figure of 8. Now, when you add the perfect figure of 8 to that egg shape, this brings exactly what we see. So it's not only about the speed of the Earth. I consider this to be a minor factor, and the main factor is the axial tilt.
Yeah, but see, my argument with it is that the globe Earth's explanation of what the globe Earth is doing comes from watching what the sun is doing. So the globe Earth had to give an explanation as to how the Analemma has a figure of 8 during a year. When it's documented, it will show a figure of 8 with a smaller loop towards the north and a bigger loop towards the south.
Your time is up, I'm afraid. Okay. Next question, Brian. You're on question 2, if you'd like to answer
okay.
that.
Yeah. Okay. Okay. This is for Crow. How can I buy a very expensive mechanical watch, a Rolex, let's just say, etc., anything that would be considered a very expensive mechanical watch, and set it to 9 p.m. at night, 9 p.m. at night at the end of May, and it still hold the same time come the end of February, foregoing daylight savings, if the Earth is supposedly slowing down and speeding up?
I don't see a relation, because your clock will always tell you the correct time, regardless to the speed of the Earth.
You see, it's for the clock is based on the sun.
Well, before you go into that, what did you think of his response first? Are you happy with his response, or would you like him to try and answer it another? Do you want to dig into something?
I would have rather a more thought out response.
Okay. Would you like to? Well, can I before you say anything else? Could you try and if that's all you want to answer, Crow, that's entirely up to you. But would you perhaps want to go into a deeper response than that?
Yeah, I'd like more clarification, because the clock is based, and as I said, it's mechanical, so it will work the same way, and it doesn't matter if you go to the moon, you go to Mars, you go to anywhere. Your clock will always count the time. So there's something in the question maybe I cannot get.
Okay. The point I'm making, is that according to the globe model, the Earth moves through June, July, and August slower than it moves through December, January, and February. Now, in June, July, and August, there's 91 days. In in December, January, and February, there's 90 days. But every 4 years, there's 91. So the point I'm making is, if the Earth is moving faster and the Earth is moving slower throughout the year, that would affect a clock or a watch, as far as that will hold the same time, but the actual time should be different, if that is what's happening. Because the actual time, because it's not the sun that's moving then, it's the Earth. The Earth is changing speed. So the point I'm making is, how could we be moving faster through December, January, and February than we are through June, July, and August, and our clock not give the wrong time?
Okay. I'll give my final answer. I understood his question. The first answer, if you're talking about relativity, because according to relativity, if your speed increases, then your perception of time changes. Then the Earth's speed is very, very small, and the relativity wouldn't kick in at that slow speed. The second part, if you give that example for 9 a.m. instead of 9 p.m., I would tell you yes, you will observe a change in the location of the sun every day at 9 a.m. when you look at your clock at the same time. That's 9 a.m. And that change in location is the analemma.
Yes, but
okay, hang on. Well, Brian, there we go. So there's his responses. Are you happy with those from his?
Yeah, that's a good response. I have no problem with that.
Okay,
yeah, that's fine.
So we'll do it. We'll get into this for 5 minutes. Okay.
Yeah. Okay.
Go ahead.
Oh, okay, Crow. As you said, the change we would see is the sun in the sky. So
yes.
we're seeing something in the sky change, but we're not seeing a change on the ground. Whereas the Earth would have to be some kind of it'd be like a semi-time machine, where it's slowing down time and speeding up time, if we're the ones that's moving. Because due to what I've read online, it's basically asserted that December, January, and February are a shorter time span due to the Earth moving faster than June, July, and August. And I know that that's not true, as I've lived in both hemispheres. Now, that's only me saying where I've lived and what I've done, so for me, that's not true. The point I'm making is, if it's the Earth that's moving and not the sun, then we would have to see a different change than just the sun moving in the sky. Because that means we are moving faster and slower. So that's why I use 9 o'clock at night. Because the 9 o'clock at night thing is that when we get around to 9 o'clock at night, when we set it in the end of May and we get around to the end of February, the 9 o'clock at night could be any time, any real time, in accordance to the fact that we're slowing down and speeding up, as we're never at a constant rate. It's constantly either slowing down or speeding up in the globe model. So the sun moving, changing in the sky is all we see. That's kind of my point. We should see more changes than that.
My final point is that there's nothing that would affect a mechanical clock or a digital clock unless you start to go like 4% of the speed of light. And if that is not happening, then there should be no change.
Well, I don't expect the watch to change or the clock to change. Like that's my point. My point is that won't change, but the actual time at that will 9 o'clock at night in the end of February be the same as 9 o'clock at night at the end of May, discarding daylight savings hour. Will that be the same? How can that be the same if we're on basically a type of time machine?
Well, how would you know
if
your clock slowed down due to that motion? How would you know that your clock slowed down?
Well, how could it slow down when it's made to do the same speed constant? Do you know what I'm saying? How would you slow down or speed up a clock? You know, that's why I said a Rolex or something. There'd be no chance of it happening.
But now you're emphasizing that speed changes the clock's speed.
No, I'm saying that the clock wouldn't change its speed. The clock wouldn't change whatsoever. But the actual time. My point is, how come people don't have to change their watches constantly in accordance with the orbit of the sun if we're going around the sun? Because they should have to change their watches and their clocks constantly, because their clocks should be going too fast and too slow at 2 different times of the year if we're going by the Earth moving and not the sun. Because if it's the sun moving, then nothing is changing down here. It's only something changing up there. But if it's the Earth moving, then the sun is staying where it is, and we're the ones that's doing the changing. If you understand.
It doesn't matter if the sun is orbiting the Earth. It could be the same thing. The sun would change its position every day during the solar noon, and the clocks will run the same. If you want to make clocks that count the day as a solar day, then this will be a huge problem, because for every location on the Earth, you will have to give different amount of time.
But the sun moving won't affect our clocks because the clock is based off of the sun. The sun moving won't change our clock.
And
but
also
what would change our clocks is us moving. If we're moving, I would expect more changes in the world. If we're the ones moving and changing speeds, I would expect more changes in the world yearly. I would expect that clocks are moving too fast at one time of the year and moving too slow at another time of year. I would expect that the clock would have to be a completely different makeup altogether if it's Earth that's moving around the sun, as we're the ones moving. So it will be affecting where we are, as opposed to the sun.
Where did you get that concept other than the theory of relativity?
Well, I didn't get it from the. I don't know much about I only know very basics about the theory of relativity. Okay. I haven't read into it.
That's your time up there, guys, I'm afraid. So,
okay.
Crowexe, would you like to ask question 3, please?
Yes, okay. So, question number 3, does perspective have any effect on how the analemma is observed on a flat Earth?
Okay, I'll read out my answer there now. 1 second. I just get it. Second now. 1 second, I just get a quick sup of water and my throat is going dry before I answer.
Ranty, would you be kind enough to prepare the image called Analemma S and Analemma N?
Okay.
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 Thank you.
Tell me when you're ready and I'll read out the answer.
Yeah, I'm ready.
Okay. The data collection for the solar analemma is going to be the data regardless of the shape or nature of the ground it is taken from. The only real main difference in perspective between the globe Earth and flat Earth concerning the analemma is the belief of what we stand on. The globe model says that the sun is higher and lower in the sky due to tilt throughout the year, whereas the flat Earth says it is due to necessity for the continued preservation, control and yearly cycles of the Arctic and Antarctic, along with providing the adequate light and seasons in its yearly cycles. We also view the sun as making smaller, higher and slower circles over the Earth plane in the northern spring and summer, and making bigger, lower and faster circles in the southern spring and summer. So the only perception difference is that we perceive the sun to be the one that's moving as opposed to the Earth. So that's the only perception difference that I could think of. Because what my point is, anything, regardless of what you believe you're standing on, regardless of whether you believe it's a globe or flat, the sun and whatever it is doing is what it's doing, and you can't argue with that. So, if you understand. Now, that I don't know if that answers your question. So, if it doesn't, you can say it.
Yeah, maybe I clarify the question.
Yeah, if you would, yeah.
Yeah. On the globe model, the shape of the analemma takes place because the sun, relative to the Earth, is higher by an angle. So we're talking about angles, not positions. Mm-hmm. On the flat Earth, you observe the analemma because a physical change of the sun's position, and it varies from altitude. I don't know what altitude, whatever the flat Earth like to give, but because it is close, it doesn't work by angles like the Earth. It ends up into an angle, but that angle is a result of a horizontal distance and altitude. So okay, sorry. Yeah. So because the analemma pattern, if we can draw it above the flat Earth, and we give it a tilt, like you mentioned in your video, to be higher to the north. Yeah. Then imagine yourself in a barn with the roof is tilted. When you look to it from inside, from one side, opposite to the other side, you'll see change in perspective due to the perspective.
I'm still not getting your question though, David.
Okay.
Crow, sorry. What is the question? Are you? Yeah.
let's say you are photographing the Analemma from the Tropic of Capricorn.
Okay,
Yeah.
guys, I'm going to give you 5 minutes starting now.
Yeah. Okay. So you are on the Capricorn. You image the Analemma, and it's like an image above you. The bigger loop is closer to you, and the smaller loop is higher for you. And by the way, that reminds me with the debate between you and Dr. Bob. Yes.
Yeah.
He was making an argument that the Analemma is reversed in the southern hemisphere, and that would be the case also on a flat Earth. It would be reversed.
No.
Well, how
the Analemma can't be reversed on either. What I mean is that yes, if you're looking at it from the southern hemisphere, what you will see is the bigger loop towards the south and smaller loop towards the north. Yes, it's reversed in that way, but it's not reversed as in the smaller loop is to the south and bigger loop to the north. It's still going to be the same.
Yeah, they're always the same direction, but you see it reversed.
You're seeing it from the opposite ends. Yeah.
So if you're on the south and the bigger loop is closer to you, then it should be way bigger perceived.
I have those images up for you if you need them.
Yes. Okay.
So which number do you need? Which?
What I would say is.
Analemma N.
Crow, what I would say, what I said to Bob when he pulled out, he had one picture from the southern hemisphere, and before he pulled it out, before I got to see it, what I said is what it will look like is the northern part of that Analemma will be lower in the sky, not lower than the southern part, but lower in the sky than we see it in the north, simply because the suns taken in that are so far away. Now, basically, the angle to them is far, so they're dropping in the sky due to angle, if you understand what I mean. And that's what I said to him before he showed the photograph. Now, they're still higher than the ones in the south, but they were not looking as high as they were in the north, because you're not looking at it from the same angle.
Well, my point that you shouldn't have argued, because that what the flat Earth model also would say. If in Argentina, for example, south of Argentina, the bigger loop is closer to you and the smaller loop. So.
Oh no! Well, at that point, what it was is that he was kind of trying to trip me up, and there was a few other things going on there. So at that point, I was after kind of getting triggered, so I wasn't thinking as straight as normal. But I still argued that I was still arguing the same point there as I am here. If you understand what I mean, it just maybe wasn't as clear. Yeah.
Can you see the image now?
I can. Yeah, I'm looking at it.
Okay, now switch to the Analemma South, and what I did in this, I flipped my laptop screen, and I made the north side, or the smaller.
Yeah, so you put the north down the way in the screen, and the south up.
Yeah, and then I took a picture from this side, looking as if I'm looking from the north, and then I switched the camera, looking from the south, and you'd see what I mean by perspective.
Just wait for it to change.
Okay, I think you can see it now.
Yes, I see what you mean. Yes.
So that's just to demonstrate what I mean. That perspective will have an effect because you are very close to the sun within the Earth region.
Yeah. Well, see, what I would say about that, what you've just shown, is what you're showing there is kind of on a flat screen, so it can't show the heights difference. But it does show what you would see in the sky. It's very similar to the southern hemisphere photo of the Analemma that Bob the Science Guy showed. It's similar to that. Now, that one had the north part cut off a bit due to it was late in the evening it was taken, I think, and there was clouds and stuff kind of in the way. But there was some stuff in the way. It wasn't as visible as that. But that is kind of what you'd see from the south up to a point.
Hold on. I would argue about the direction of the Analemma because, as I said, they are both the same in globe or flat Earth. But the point is, the Analemma on the flat Earth is made for certain points on a certain solar noon time for that point, based on the physical location of the sun, plotted along the year.
Yes.
So that what you should see, and also I made the screen tilted, and if it's not tilted, it will be almost the same effect. And
yeah, I mean,
Okay,
looking
your
from
time
the
is
ground.
up there, I'm afraid,
Sorry.
guys. I
Yeah.
am
Okay.
whizzing through these questions. That was question 3 from you, wasn't it, Crow? So,
yes.
Brian, would you like to ask your question 3, please?
Okay. Yeah. 1 second. Yeah.
Oh, before you actually get into it, bear in mind that at the end of this, I'll give you 15 minutes to go over anything that you feel that you haven't addressed, or actually get into the crux of why you had these 5 questions. You know. So.
Okay. Yeah.
Okay. So
yeah,
go
fine.
ahead. Go ahead, Brian.
Okay. Okay. Right. Okay. Crow. It's my 3rd question.
Yes.
If this supposed tilt of the globe Earth gives us our seasons, then how is that relevant in the northern hemisphere summer when our tilt towards the sun is only a couple of thousand kilometers, but we are 4,800,000 kilometers supposedly further from the sun than we were in our winter? Taking this into account, how is the tilt even relevant?
Okay, so Randy, please. There's a picture called N and S. November and Sierra. N and S.
Analemma N or just number N and
No,
S?
just N and S.
I see it. I see it.
Okay, so yeah, so first of all, the tilt of the Earth, it shouldn't imply that we get closer to the sun by a few thousand kilometers, because the Earth is a ball. A ball, no matter how we tilt a ball, the distance wouldn't matter. And even
well, I kind of disagree with that now. I have to disagree with that. It depends on what part of the ball you're on.
Okay, yeah, you get closer to the sun by maybe, say, 5,000 kilometers, but
Rupus worked it out at 2,600. Now, I don't know if that's correct, but he worked it out at 2,600
I'll take that.
kilometers. Now, I don't mind going by, he's pretty good at maths, and he did it there and then, so I won't argue with that.
Say 6,000, that's the whole radius of the Earth. Even if the Earth got closer to that 1,000 divided by 150 or 147 millions, that's very, very, very tiny. It shouldn't matter. But what makes the seasons is if you can. Are you showing the image now, Randy?
I am. Yeah, I've been showing it for about a minute now.
So so the image here, and if you can see.
Yeah, I can see an image where there's a section, like a quarter section, or a bit more than a quarter section in brown of the Earth.
So the red line represents the plane of the orbit of the Earth. There's bottom, below it, and the top. But that's not. That's almost irrelevant. What matters is the vector, or the axis of rotation, as you see in the upper left corner. That's the direction of the north. So the area that I painted in red is like the jurisdiction of the Earth that falls under the north hemisphere and taking sunlight. So all that area is taking sunlight in that snapshot of time. And for the southern hemisphere, the area in blue, this is the only area that's taking sunlight in that snapshot of time. That's not the only factor, but there's another factor, that the sun is perpendicular on that red line. That's around. Do you see the Arab Peninsula?
Sorry, say that last sentence to me. Do I see
the Arab Peninsula?
I don't understand that. Sorry, I can't understand.
Okay. The red light. That's where the sun is perpendicular to. So the sun is. Yeah,
the red line, you're saying, the red line?
Yes, on the red line, the sun coming from the right is perpendicular 90 degrees of elevation on that point. So that is the most heated point. So those are two factors that creates the season. The angle of the sun, let's say the highest temperature of the sun is within the jurisdiction of the north hemisphere. And also that the north hemisphere has more area seeing sunlight during summer. But that's the season.
Does that answer your question there, Brian?
I don't think so.
Yeah, well,
not.
it doesn't answer it for me, but it is a good answer, and it was the answer I expected that Crow would give.
Okay, I'll give you 5 minutes to get into this.
Yeah,
Then.
yeah.
Okay.
Okay, Crow. Not to sound condescending or anything like that. That's what I did expect you to give that answer, because of the tilt of the globe Earth at 23.5 degrees. At the start of my presentation on the Analemma, that was the first thing I talked about, was the tilt and the seasons, and how that's constantly tilted. And in the northern hemisphere of summer, it's tilted towards the sun. Now, a lot of time, the argument is that the sun rays are hitting the northern part of the globe Earth straight on, and hitting them at an angle that will give more, let's just say, heat and that to the Earth. But if the sun is 93 million miles away, then it shouldn't matter what tilt the Earth is at, because if they can hit the northern hemisphere with that much intensity, just at that small angle change, it shouldn't matter. The intensity shouldn't change from north to south. Really, we should have, going by the globe Earth model, including the globe Earth model sun and straight parallel lines of rays that the globe Earth model says we should have, basically, everyone should have summer at the one time, both north and south, and everyone should have winter at one time, and spring and autumn, and they should all be extreme seasons. Like, winter should be an extremely cold winter. Summer should be extremely hot summer. Because in the summertime, in the southern hemisphere, we are 4,800,000 kilometers closer to the sun. So there's no way the tilt in the northern hemisphere summer would matter, because if we can be only tilted away from it by a few thousand kilometers in the southern hemisphere summer, then it doesn't matter if we're getting straight parallel rays from the sun, like we're supposed to get in the globe model. If we're getting straight parallel rays, then they should be hitting the whole thing evenly. There is no way that a tilt like that is going to affect if the force and power from a sun that's able to travel, that's able to send its rays that far. I mean, the tilt, you could argue, in the northern hemisphere summer should have an effect on the Earth, but so should the tilt in the southern hemisphere summer. But the tilt should affect the whole Earth the same way, and not one half and the other.
Hold on, I was first explaining the seasons and not addressing the issue of being closer or further from the sun. And as you see, there's more area under the jurisdiction of the northern hemisphere seeing direct sunlight. All of this area is seeing direct sunlight, not just the daylight after sunset. So that's one factor, and this could be the biggest factor. I'm not sure, and there's another factor that the sun is perpendicular. Now there's issue here. We have colder temperature the higher we go, right?
Yeah, we have colder temperature. Are you talking about altitude?
Yes.
Or elevation? Yes. Yeah.
Yeah, this temperature drop. Maybe at the higher, very higher, call it thermosphere, it is more hot. But
well,
maybe
yes, what we know for definite is on the ground it's warm, and as you go up, let's say, the top of a mountain, it gets colder if it's very hot. Yes. Is that what you're talking about, kind of?
Yes, and if the sun energy is directly heating the atmosphere, then what you're saying is correct. But that's not true, because we have colder the more we go. That assures that the major or the significant factor of how the Earth atmosphere gets heated is through conduction. That is heating the surface of the Earth. And if you are projecting a light vertical or energy vertical to a surface, that surface gets more heated more than if you are projecting that light in an angle.
Yes, but what heats up the surface is the interaction between the sun rays and the air molecules.
No.
That's how hot air. That's how we get high pressure. That's why you have such high pressure at the ground level. The high pressure at the ground level comes from the hot air, and as that rises, that gives a pressure gradient because the hot air starts to cool down.
The
If you understand what I mean, it's like the heat we have on the ground level, the high pressure we get in our summer times, let's just say the higher pressure we get in our summer times than our winter times, come from.
Your time's up there, I'm afraid again.
Okay.
we have high pressure in the Antarctic and North Pole. So.
Yes, but not. Yeah, we do have, but not to the same degree. Like we wouldn't have the same as we would have in California.
Okay, well, you guys can get into this in the 15-minute after the questions if you like.
Okay.
But Crow, if you want to ask your next question, that'll be question 4.
Yes. Okay. Question 4: the flat Earth sun, when above the Tropic of Cancer, should be slower than that on the Tropic of Capricorn. True?
Yes.
Did you inspect the angular speed of the sun during zenith for different location? For example, when above any of those tropics as observed from the opposite one.
Okay, I'll give you my answer now. I wrote it out so I could give you a proper answer because I can be a bit forgetful.
That's perfect.
Okay. Okay. So have I measured myself? No. The reason I didn't is, as there is irrefutable data stretching back to ancient times concerning the sun's movements in our sky. And it is what the Analemma explanation for a flat or globe Earth is based on. The one main difference between the two explanations being that we are stationary on a flat Earth, but we are supposed to be moving on the globe Earth. The only way to calculate the Analemma is to study the sun. So if the sun was not moving faster across the sky in the southern summer and not moving slower across the sky in the northern summer and changing heights throughout the year, then both explanations, whether globe or flat, are incorrect. The globe's speed changes that it is supposed to have would not have been implemented into the globe's Analemma explanation if the sun was not seen to be making faster movements across the sky when it's over the Tropic of Capricorn, or slower movements across the sky when it's over the Tropic of Cancer. There would have been no point in adding that into the globe explanation, as it would not have reacted to reality. For both the flattened globe, the Tropic of Cancer, the equator, and the Tropic of Capricorn are all circle ribs of the sun. The only difference is the Tropic of Capricorn is bigger in diameter and circumference on the flat Earth, hence the faster sun.
Okay, so my point is, the distance from the Capricorn to Cancer, say 10,000 kilometers. Okay.
Well, how did he answer the question? Did he answer the question fully enough for you?
No, it diverted to comparison between the globe and flat Earth, and that's why I'm asking the question.
Okay.
I can explain that if you want.
Hang on. If you're refining the question, that's great. So if you want to refine your question, and then if you want to try and answer that again, if you can, there, Brian. Cheers.
Okay. Yeah.
Okay. So when I say, did you inspect the angular speed? Some things we don't have the tools to inspect, but there's other things that makes it easy, and it's confirmed. Like, for example, going to time and date, and find whatever information you'd like to have. So if we say that the distance from the Capricorn to Cancer is 10,000 kilometers, and we have two observers, each one is going to observe the sun when it's on the opposite tropic. Now, the one on the Cancer is going to observe a sun at the distance of, say, 10,000 kilometers.
Yes.
And it's moving fast. And the other one from the opposite side, also the same distance, or maybe even more, because you say that it is on the north, higher on the north, and it is slower. And that would result in a change in the angular speed of the sun during zenith, during this solar noon.
Yes. Well, I'm going to use your globe Earth explanation of the Analemma. I give a more concise answer. The globe Earth explanation of the Analemma has us moving slower in the northern summer and faster in the southern summer. But that only comes from watching the sun. because it's only the study of the sun that gives us the Analemma. So in the southern summer, right, the Earth is supposed to be moving 67,777 miles per hour past the sun, and in the northern summer we're supposed to be moving 65,520 miles per hour past the sun. Now, the only way to calculate that is by what the sun is doing in the sky. So the Earth has to slow down by 2,250 miles per hour for to have the northern summer on the globe model. The point I'm making is that if the sun does not change speeds in the sky, then why would that be in the explanation for the globe Earth Analemma?
Okay, I'm going to give you 5 minutes to get into this, guys.
Okay, again, this question is all just about the flat Earth. How come we don't see that the sun, as observed from the north, when it's winter for the north? It should be going faster than someone who's on the south observing the north sun.
See, the thing about it is that if you go looking into that and find out, if you ask Google the question, does the sun move faster in the southern hemisphere? What you get is, what you're told is, the Earth is moving faster.
No,
the southern hemisphere, somewhere you're told the Earth, because all mainstream, it'll say, I remember reading about it, and it said, the sun apparently moves faster across the sky in the southern hemisphere of summer, but it's actually the Earth moving faster. So all the data for the globe's Analemma comes from watching the sun. So if the sun is not moving faster in the southern hemisphere summer, and it's not moving slower in the northern hemisphere summer, then the globe explanation for the Analemma and the flat Earth explanation for the Analemma are both completely wrong, because the whole data comes from watching the sun. It's the study of the sun, the solar Analemma. And if the sun is not moving faster and slower across the sky in those 2 times a year, then both explanations are wrong, and the two of us are arguing about 2 wrong explanations, trying to make it right out of 2 things that are wrong, which won't happen. That would be none of us know. You understand what I mean?
Well, you're confusing me with bringing the globe into the question.
I have to bring the globe into it, because if you're trying to find out whether the sun is moving faster and slower throughout the year on the flat Earth, and has it been studied, it has been studied, but they don't explain it as the sun moving faster. They explain it as the Earth moving faster. Do you understand what I mean? The explanation is the Earth is moving faster and moving slower. But they came to that explanation by watching the sun move faster. But the people who watch the sun move faster believe that they're on a globe and they're the ones moving. So they believe the sun is stationary, but it's like being in a car or watching a car go past you. 2 different cars at 2 different speeds. But you believe you're standing still, but you believe that you're the one moving. So you went past one car fast and the other car slow. Whereas the flat Earth explanation is that the first car went past you fast and the second car went past you slow. Do you understand what I mean? It's like any questions like that you ask about the flat Earth, you have to go back to the globe explanation as well.
The globe has 2 versions. There's the heliocentric model and the geocentric model. They both agree, even though in one model the sun orbit, and the other model the Earth orbit. They both agree, and they can come up with the same observation and the same calculations.
Yes, they both agree that the sun moves. That they both agree that that in the northern summer the sun is moving slow, and in the southern summer the sun is moving fast. In the geocentric.
Well,
because that's the same as the flat Earth, if you understand what I mean.
Just for the audience, when you say fast, that's 1.035, because I don't want people to get wrong impression.
Well, I have to go by the speeds that you have to take into account that the explanation of the speeds that the Earth is supposed to be moving is 67,777 miles per hour in the southern summer and 65,520 miles per hour in the northern summer. So you can't scrutinize the Analemma on the flat Earth without scrutinizing it on the globe Earth. You can't do that because the globe Earth's Analemma comes from watching the sun. All the data comes from watching the sun. So if the sun wasn't doing these things in the sky, the difference is that we believe we're stationary, whereas your side believes that you're moving. So if the sun is not doing these things in the sky,
no, I said it doesn't matter if the sun is moving. I say it doesn't matter if the sun was moving. We'll get the same result if it's orbiting the Earth with the same orbit parameters. So
but if it's the same result, then what's the argument with the flat Earth? As far as the speed goes, because the same result would have to be the same on the geocentric globe model as it would be on the flat Earth. It would have to be the sun moving faster.
Okay, your time's up on that. Again, very quick, innit? Guys.
Yeah, the most fast. Yeah.
Guys. So we're on question 4 for you now, Brian.
Oh, it's my fourth one, Randy. Okay. So now. Okay. Okay, I think this is somewhere along the same lines of what we're talking about. Okay, Crow, if all the data for the solar Analemma comes from the study of the sun and its movements in our sky, then would you agree that would have to have been back engineered to fit an ideology where we are the ones moving as a supposed planet and the sun is the more stationary object in that ideology? Do you want me to repeat that?
No, I got the question. I have it in front of me.
Yeah.
Okay, so if all the data for the solar Analemma comes from the study of the sun and its movement, then it is back engineered to display the sun movement. I don't know how would that fit to an ideology. If I'm watching someone building a car, and I'm taking notes of what he's doing, and I leave that paper to someone, he is not going to build an aircraft. He's going to build a car also. So if we observe reality and take notes and try to analyze and come to a conclusion, and when we put that conclusion to scrutiny, we can predict the reality, and that's what I did. I took the information of the globe, how the eccentricity of the orbit, the axial tilt, and the rotation of the Earth. I put them all, and I plotted the Analemma on a chart without observing the sun. So that's what I did. I reverse engineered the model, or those three numbers, or the three details, are the notes that people who observed the sun came up with: the tilt, the rotation speed, the orbit. So I took these notes and I put it to work, and it brings what we see in reality.
Okay, does that answer your question there, Brian?
No, not really.
If you want to be
it does and it doesn't. It doesn't. I won't say it was a bad answer. I wasn't a bad answer, but what I would say about it is,
well, if
it wasn't a bad answer. It wasn't a bad answer. It's not,
okay. Well, I'm going to give you 5 minutes to get into it then.
Okay. Crow, the point I was making about it is everything we know about the solar Analemma has to come from watching the sun. So in the flat Earth model, we just believe that we are here and the sun is doing all these things in the sky. Whereas for the globe Earth Analemma explanation to exist, the globe Earth had to reverse everything and back engineer everything, so we were the ones moving and the sun stayed. We went around the sun, and the sun more or less, although the sun is moving through in that model through the universe and whatever, we basically were the ones moving around the sun. So the point I'm making is, for that to happen, it meant that there was all kinds of twists and turns, these differences and distances from the sun. There had to be the tilt. All these things had to happen, and all these two different speeds of the Earth, one in the northern summer, one in the southern summer. All this had to happen to explain what we are just looking at in the sky, due to an ideology that we were the ones moving. So my point is that Why is it not just that's moving?
I think
is that not a simpler explanation?
Stationary. I think the ideology, the first ideology was the Earth is flat and stationary. Then they came up with it's a globe, but it's stationary. So that is the ideology. When you say, I believe so.
Yeah, but when they had to put the Earth moving around the sun, when the people who believed in the globe had to make it move around the sun, and they had to explain the Analemma, then they had to do. The point I'm making is that to explain the Analemma on the globe Earth, we need a lot of crazy kind of twists and turns and different speeds of the globe, and at 2 different distances from the sun at 2 different times of the year, and there had to be a tilt. There seemed to be like 3 or 4 things that had to be twisted around just to get us to just to get the globe model to fit being the one going around the sun. Whereas my point being is the flat Earth explanation of the Analemma is a far more natural and balanced explanation, where the sun does all these things and we just stay as we are.
That's not an explanation.
Because the sun is what we're watching, because we can't take any Analemma data without taking it from the sun.
The flat Earth describes...
I know you said you did it.
I was saying there's no flat Earth explanation. There's only flat Earth description of the position of the sun on certain dates.
Well,
so that's a description, not an explanation of why things happen.
What do you mean by not an explanation?
An explanation like the reason what makes the sun relative to us behaves that way. For the flat Earth, they say the sun on a certain date it would be there, and then it would be there, and then it would be there. So it is merely a description of the sun, how the sun is supposed to move in order to fit the Analemma. But
well, go on, say. Yeah. Go on, finish what you're saying.
Okay, like for example, I tried to make something like a sun calculator or Analemma on a flat Earth. I had to find the basic or the concept of sun movement. So the first one, I presumed that the sun accelerates from the south until the north, until the equator, and it starts to decelerate again, slowing down. And I give it a certain amount of acceleration to work that, but no amount of acceleration is working. What I mean by that, I was just trying to make a concept of how the sun is moving, but it doesn't. I couldn't find one.
The official sun data is what you need, because if the sun is not doing that, then both explanations, both flat and Earth, have to be thrown out, or flat and globe have to be thrown out the window, because the globe can't be going. The globe can't be going faster and slower in the year if the sun is not going faster and slower through the sky, because all the Analemma data comes from the sun. Do you understand? Every piece of data you have on the Analemma comes from the sun. So for the globe model to be going faster in the southern summer and slower in the northern summer, past the sun, then that means the sun has to be doing it. Otherwise, both explanations are completely wrong, and this is a complete pointless waste of time.
Well, no, I disagree to that, because we observe the sun, for example. Although I'm not very comfortable with this concept that people observed the Analemma and then predicted how the world looked like. But the point is, we observed the sun and we thought, okay, then we must be speeding up and slowing down. And I also don't
why would you come to that? Why would you think we're going speeding up and slowing down?
Well, you can get into this in a minute, because that's your 5 minutes up, I'm afraid. Right, final questions. So question five, and then what we'll do, we'll allow you 15 minutes just to go back over anything and just basically have a chat with each other, bring up why you actually feel that you've led the opponent down a path that you can hopefully claim a victory on. So, Crow, if you'd like to ask your last question, that would be great.
Okay, my last question. In the heliocentric model, the Analemma has 2 axes, and the change on each axis is well defined and can be calculated upon the heliocentric model information. Those are the 3 informations that I mentioned. Are there reasons, or are there any reasons or mechanisms or motives for the sun to move along the Analemma paths on the flat Earth?
Yeah, it's basically give a description of why the sun does what it does on the flat Earth. or an explanation for it. Okay, this is kind of longish, so I'll try and keep it as concise as possible. Okay, answer number 5 for your question. The Analemma path and reason on the flat Earth is as follows. The Sun will be higher over the Tropic of Cancer and make a smaller circle of the Earth to protect the Arctic for balance, making sure that the ice sheets do not get obliterated to the point of no return. Hence, also protecting all the animal, plant, marine and human life that live in the Arctic Circle. Also because the Sun, is making a smaller circle above us. If it was to be as low in the sky as it is in the southern summer, then it would cause evacuation of the surrounding area of the Tropic of Cancer, as the heat and radiation would be too extreme. Due to its low position in the sky and the fact that it gives that region of the Earth such long summer days and short nights, there would not be enough cooling off period if it was lower in the sky at that time of year, taking all other factors into account. On top of this, if the Sun was not at the height it is shown to be by the Analemma at that time of year, then the southern hemisphere would not get adequate light and heat for balanced survival, thus allowing Antarctica to grow more than it should, as the very southern seas would freeze. When the Sun is at the equinox positions, it is either about to speed up or it is slowing down. When the Sun reaches the September equinox, it has been moving slowly, so it is behind its time, and this is possibly why the September equinox is always a day or two later in the month than what the solstices and the March equinox falls on. But this is also connected to calendars. On top of this, the Sun is making a wider and lower circles when at the September equinox, and will continue on this path until it starts to rise again with tighter circles after early January. From the March equinox, the Sun will be continuing to rise and slow and continue to tighten its rotation circle until after early June. When the Sun is in the southern summer, it is moving at its fastest pace and is at its lowest in the sky and making its biggest circles around the Earth. The reason for this is to not melt the upper ice shelf of the Antarctic, but more for to melt the ice flows around the southern seas and melt back the coastline of Antarctica a little to keep it in a balanced state. The Sun will also be redundant in the Arctic Circle at that time of year, allowing the Arctic ice sheets to freeze again, allowing it to keep its structural integrity, creating a several-month darkness for the Arctic Circle. The Antarctic does also get a period of darkness during the northern summer. Most of the behaviour of the Sun over the flat Earth throughout the year is based around keeping a master balance over the Earth, creating just the right amount of life and death, and creation and entropy, to make sure that everything keeps working as it should, like a 12-month solar clock. Because the southern hemisphere experiences a closer Sun, it does supposedly get 7% more Sun intensity. But the Sun does move faster across the sky at that time of year, so it spends less time giving light to the most populated areas. So the day/night balance is not as extreme as the north throughout the southern year. And life in general, not just human, is very, very sparse past the 59 parallel south. So the oceans absorb a lot of the extra Sun intensity caused by this closer Sun, hence melting the ice flows around the Arctic waters. And to close this answer, most people living in the south would be living from the equator line out to about the 45th parallel south, whereas in the north people live all the way into the Arctic Circle, and even on the Arctic itself we have the Inuit tribes, something we definitely don't see in the south. That's my answer.
Wow, that was quite the answer. What did you think, Crowexe? Did that answer your question?
It's an answer, but the answer gives me an idea that the Sun has a mind of its own to preserve life on Earth. It's just like
I'm going to give you a 5-minute session right now, so you can get into this. Okay. There you go.
So what I'm saying, the Sun says, I must do this and do this and do that in order to keep life on Earth. Well, that's not much of an explanation. Yeah, that's a motive for the Sun. If the Sun was like a living creature that's taking care of the Earth.
Our belief is that we have a creator, that we have a God, that the Sun is built to do that. Not the sun has consciousness; it's built by consciousness. If you understand what I mean.
Yeah. By the way, I'm a globe earthist, but I'm a very strong believer, and this could be a little bit sidetrack. I'm sorry,
Yeah.
but
I'm not saying that you're not a believer in God. I'm just saying that would be part of the reason.
Well, I believe that the most amazing miracles are the miracles that, which step leads to something and leads to something. God could say, let be whatever there is. Let the sun move this way. But his biggest miracle is the way that he engineered the universe that we live in. So I don't believe that the sun has a mind, but I don't believe that the God commanded to move that way. But the God made the rules or the mechanics for the sun and earth to work together and interact in that way.
Well, see, I believe in God. I believe in the Creator too. And for me, the sun and the moon work side by side. The sun gives life. Gives life. It is an entropy. It does create entropy too. But the sun gives life, and the moon creates entropy. So the sun creates life, and the moon takes it away. That's how I would feel. The moon is a very big entropy creator, let's just say. But talking about the sun, I believe that the sun and moon are not as far away and the sizes that they're purported to be in the global explanation, and that we are a lot more local. And the universe is not what we think it is. Whatever the universe is, it's not what we're told. That's just my belief. So I can't say this is a fact or that's a fact because I can't prove that. Let's just say I can't prove what a star is or what a star is not, if you understand what I mean.
Yes, I understand. So, well, my point again, I go back to the same issue of reverse engineering, taking notes of how the world work, and then give these notes to anyone, and he will tell you that the globe works this way. It's like.
Would you
like?
Go on.
Go ahead.
Would you explain to me why the globe slows down and speeds up then at 2 different times of the year, and how they came to that? Why they came to that? Why that's in the Analemma explanation, and how they came to it?
Well, I'm not sure, but this comes from orbital mechanics, and orbital mechanics is based on observation of the
skies.
Sky, how things, yes.
So
they came
would
to the
it
conclusion
not make sense that it's the sun, considering all the Analemma data comes from the sun?
Say again?
Watching the sun, would it not make sense that it's because of what the sun is doing? It's because of the sun changing speeds throughout the year? Would that not make, because the globe, there'd be no reason for the globe explanation to have the globe going faster or slower if the sun wasn't doing that in our skies.
Well, before it becomes to be an explanation, it was an analysis.
But everything has to be worked off of the Analemma. Like you can't explain the Analemma without working off of the Analemma.
Without what?
You can't explain the Analemma without working off of the Analemma. The point I'm making is the only reason that is in the globe explanation is because the sun does speed up and slow down throughout the year.
No, actually, that's a minor issue because I already say that if we try to take the orbit speed change and try to put it in an Analemma, it comes out as an egg. And if you throw away the orbit mechanics.
An egg from what though? If it comes out as an egg from what? From what vantage point?
From any observer on Earth looking at the sun along the year.
Yeah, but when it's calculated, is it being calculated by somebody in the belief that they're on a globe? Are they calculating it like that, or is it calculation from belief we're on a flat plane?
Okay, that's your 5 minutes up, I'm afraid. You'll have to hold that thought. So, final question from Brian. I believe it is your final question, so...
Oh, yeah, sorry, I forgot about that.
Away.
Okay. In your opinion, for Crow, now that you are privy to both the globe Earth and flat Earth explanations, of the solar analemma, which explanation of the two seems like a more plausible and natural explanation for the analemma that we record, and why?
Okay, for me, I see that the globe is a better explanation, and that's because I omit the explanation of the flat Earth because I consider description rather than explanation.
Well, I would be the same concerning the globe, except for I would see it as the globe is just reversed engineered what it sees the sun do in the sky.
Yes.
Because to prove the globe explanation of the analemma, a lot of other things have to be proved before you could even prove that. Whereas the flat Earth explanation of the analemma, we just have to prove that the sun is doing what it's doing, which is proved every day by what it's doing. What it's doing is exactly what it should be doing, and that gives us the analemma of the sun on the flat Earth.
Why do you say it should be doing? That should be doing is based on a sun that has a mind on its own, doing things that cannot be explained.
Well, no, it's not doing anything different. The sun in the sky, the point I'm making is that the data for the analemma, regardless of what you believe in, whether it's flat Earth or globe Earth, the data has to come from watching the sun. So
yes.
There's nothing that's made up here. The sun is doing what it's doing. It's the reasons why it's doing it, or the explanation I give for the flat Earth, the reasons why it's doing it, make a lot of sense. It's not that the sun has a mind and it's doing its own thing, but it's created by it. It's not so much the sun is a consciousness, but it's created by a consciousness to do that exact thing. And it does it constantly, all the time, year in, year out. Excuse me, at the bench. I don't think that you gave that a very good answer, because you just kind of hand-waved dismissed the flat Earth explanation without explaining all the problems, without taking into account all the problems with the globe Earth.
Okay, well, before you get into it any further, if you want to sort of like go through the point of the question that you actually want addressing, and then if you could try and answer that, please, then, Crow.
The reason I asked that question was, what I wanted was a balanced look at both of them, and the explanation for why the sun does what it does on the flat Earth explanation, and the explanation for why the Earth does what it does on the globe Earth explanation. My point being is that I fully believe that the flat Earth explanation fits what we see and reality, and makes far more sense, is a lot more balanced, a lot more natural, and a lot more real than the globe Earth explanation, as so many other things have to be proven before you could even try to prove the globe Earth's explanation of the analemma.
Okay, you know, if you're watching someone who's making shadows on a wall, you know that people makes things with their fingers as if they're animals talking.
Yeah.
If let's say two people are observing this, but one person say this could be a rabbit, this could be just a shadow that we have no explanation, but it does what it does, while the other tells you no, he does his finger in this way, and he shows you that the certain movements, certain fingers behind the light would cast the shadow as you see it. That's an explanation. So the sorry, 1 minute. So the ancient people, and I'm not very familiar with the history of science or stuff like that. They observed the the analemma and the sun and the stars, and they tried to make sense. Why do we see this? And when they asked themselves this question, they gave an answer that the world that we live in looks this way. But that process is missing in the flat Earth.
But how long ago are you talking about? When you say,
okay, guys, I'm going to give you 5 minutes to get into this.
Okay.
So you've had the response. So here we go.
So how long ago are you talking about that they decided that the Earth goes around the sun?
The Earth goes. I don't know when did we revert or reverse from geocentric to heliocentric. So I'm not sure. I don't know.
The oldest globe that can be found is from 1492. That's the oldest globe that can be found. There's no globes before 1492 that can be proven.
Okay.
So the oldest actual physical made globe is from 1492. And I looked at it in 2016, and it was a kind of a botched together, sewn up kind of animal skin thing. And now, if you look at it through Google, it looks very pristine as made by a German cartographer. The point I'm making is the belief that the Earth goes around the sun can't come from several thousand years ago, because there is no evidence of a globe being made back in those times by stonemasons or metal workers or anything. And back in times of the Greek, they had the best stonemasons in the world. During the medieval times, we had the best people working with steel, as for armor and all this kind of stuff. So the oldest globe in the world is from 1492, the same year that Christopher Columbus supposedly discovered the Americas. So you kind of have to look. Yeah, kind of have to go right. When did they decide that what happens is this and not the other thing?
Well, as I say, I don't have historical knowledge of the progress of this process, but I don't even know Kepler. What was his time? Do you have any clue?
Well, they say Johannes Kepler. What they said was there was I have 1619 was when he came up with his astronomical unit, supposedly. Okay, and the first kind of measured distance to the sun was done by Edmund Halley in 1716, if I have it right. But that's what they say. But that doesn't mean it was a mainstream view, if you understand what I mean. That doesn't mean it was a mainstream view. And we don't know if them years are correct. So all I know is that's me. But we don't know how correct those years are. That's just what we're told. But the oldest globe that can be found is from 1492.
1492. So you're saying that because there was no orbital mechanics at that time, this was just some kind of crazy idea of someone, and then people came after him trying to humor him and confirm it or prove it.
What I'm saying is that there's a common belief that way back a couple of thousand years ago in Greece, that everyone believed that the Earth went around the sun, it was a globe, and that it was way back in the ancient times was the last time people believed in the flat Earth, and that they were shown that they were kind of wrong by the ancient Greeks and this kind of thing. But that has not been proven to be true. The oldest globe is from 1492, and the flat Earth belief has gone on through the centuries. It's only in the past couple of hundred years that the globe Earth belief has been the mainstay belief in the world. Before that, the flat Earth belief was the mainstay belief.
Well, like for example, now we believe in relativity, but maybe a few years later, some scientists will debunk it and come with another explanation for things.
Well, I don't know if I believe it, if you understand what I mean. I can't say we all do, but in general, people in the mainstream science believe in it. I can't say I believe in it because I don't know enough about it. But if it involves the curving of space-time and stuff like that, then I probably wouldn't, because I haven't been able to find any solid evidence for it.
Well, anyway, I would like to see someone debunking him, because it doesn't make sense to me. Maybe I don't understand it. I just don't feel comfortable with it. But the point is, the science or the scientists, they are in constant effort to try to explain things, and the better for them if they debunk something that was an older idea, or make it better. So science always progress, and there's a motive for that. Everyone wants a piece of that great scientist. If I can debunk him, then I am the best. So
what you're debunking an ideology. You're debunking something that hasn't been proven. Somebody who had a theory that hasn't been proven, because what's space-time? How do you coordinate?
No, let's
things like that.
With the relativity, because I don't understand it, and we both feel the same about it.
Okay, the time is up, I am afraid. That's all your questions asked. That's the 5 minutes with each. It's been a very cordial chat, I have to say.
Yeah, it's been very good, very good. Thanks,
Yeah.
Crow.
There hasn't been a raised voice at all. That might change in the 15 minutes that you two get to debate each other. We still
I'm
don't
going to try
know.
to not let that happen. I'm going to try to not let that happen.
It's
No,
unlike.
it's not
I hope not, because essentially that will be unscripted. It will just be a case of you'll be using the 5 points of the questions that you brought to the table, the opponent's answers, and hopefully trying to claim a victory of some sorts. In the meantime, I'd just like to show this to the audience. So, I have started up a Patreon for the Round Table. So, for as little as $1 a month, $1 a month, and guess what I've called it? A lumberjack. I love it. For all my little trolls out there that seem to remember the lumberjack thing when I was talking about that on Patricia Steer's channel. If they want to be a lumberjack, they can support me for $1. And obviously we've got some different tiers going up there. We've got the Jester, etc., and the Squire. So I'm hoping to get to in and around about $300 a month. That would be ideal to do the round table in the current format that I am actually doing it in. So if you do feel that you can support the show, I would appreciate it very much. Now then, now that that's over and done with, let's get back to the debate. And
Yes, support Randy.
thank you very much.
Yes. Yeah, I do like this show a lot. It gives chance for everyone to express what he has and share, and hopefully debates like this calm, and I'm sure that people on both sides learned things, even things about the flat Earth or the globe Earth, and but I'm not sure if such quiet or calm debates are good for your show, because some people like to watch blood.
Yeah, of
Yes,
course.
yeah.
But I'm really not too bothered about the blood or anything like that. I just want to have a debate where we get some quality people coming on to discuss why they believe the shape of the Earth is the shape that they can prove it is, or not. You know, I mean, a lot of the presentations will fail, and they'll be exposed through their lack of proofs. So. Essentially, that's what I'm trying to get through. I'm trying to cut through the bullshit, and let's just get to some answers, you know. Anyway, 15 minutes, guys. I'm going to give you 15 minutes. If you two want to crack into it, literally, the floor is yours, and away you go.
Okay. What parts of the Analemma, flat Earth Analemma, do you have the biggest problems with, Crow?
Okay, let's. If we ignore the explanation, the biggest issue I have with the Analemma is two observations. The first observation is two people on opposite equators looking at the opposite Analemma. Due to perspective, it should look very much different. Not just upside down. Upside down is okay, but it would look very different from two different tropics. The other thing is
well, if you mind if I answer that first, and then I'll go on. We'll move on to the next part, right? How about that?
Yeah. Okay.
For the Analemma, because the northern side is higher, when you're in the north, all right, or even close to the equator, but when you're in the north, you're going to see that more more personified, let's just say. Okay.
More what?
Personified, more illuminated, if you understand. You're going to see the higher sun and lower sun more personified from the north, because the north is where the highest sun is. From a photograph of it, a time-lapse photograph from the north, photographs from the north is going to show that more personified. From the south, what you would see is you're going to see the high sun that's in the north will be lower in the sky than, not lower than the suns at the south, but it will be still lower in the sky than you'll see in the north. And the reason for that is because when you're looking from the south towards the north at the higher suns, they are higher in the sky, but they are further away, as well as being higher, they're actually further in your field of view. So they're going to drop in the sky a bit. So it won't look exactly the same from the south and the north. It won't look exactly the same. In the north, it'll look almost kind of like, not upright, but it'll be tilted towards you in the north. Whereas in the south, you're looking up along it, kind of thing. If that gives an explanation.
You were going just fine until you say they will look the same orientation. Do you mean the same orientation?
What I mean is that if you're looking at a time lapse of the Analemma from the north, you're looking at it tilted towards you. Basically, the north is tilted towards you, the south is tilted away from you, and the north part of it is higher. Whereas in the south, if you're looking at it in the south, you're going to see mostly the southern part, which is the biggest part, and you're going to see the northern part, but it's going to be lower in the sky than it looks to you from the north, because you're looking up at an angle to it, as opposed to along. It's like, if you can imagine, you're kind of nearly looking at along the back of it, as opposed to along the belly of it, if you understand what I mean. That when we're looking at the Analemma, it's sort of in the northern hemisphere, it's like looking at the face of it. Whereas from the southern hemisphere, you're nearly looking up along the back of it. It's like, if you understand what I mean, it's like
but you in both cases you are below the Analemma, so you cannot see it from the top.
No, in both cases you're looking up at it. In both cases you're looking up at it. Yeah.
Yes, both points. Let's call it the north point and the south point. Those are the when it's on the equator and sorry, on the Cancer and Capricorn. So if you're in the north on Capricorn, and you take an image of the Analemma, the higher loop or the smaller loop is closer to you, and the bigger loop is further away. And due to perspective, it should look a little bit smaller. And the opposite is true. When you are on the south, you see the big loop is already bigger than what it should be.
Yes, because you're closer to it.
Yes, but that we don't observe, and not just. Well,
we do observe that.
Okay, hold on. Let me ignore
because even Bob had a photograph. Even Bob, the science guy, had a photograph which showed that. Well,
no, it changed in tilt, but not the shape. The shape is.
Oh, the shape is not going to change. The shape is going to stay the same. Like, I mean, if you're in the southern hemisphere, the big loop is going to be at your side, and the small loop is still going to be towards the north. That's not going to change. It's not going to change. Like, the big loop is always to the south, so the small loop always to the north. That's never going to change.
Yes, that's not going to change. But due to perspective, it's going to change. But even that, I'm not interested in. What I'm interested in is the sizes of the loops. When you are closer to the bigger loop, it should be bigger than it should look bigger. And when you're
it depends on what latitude you're at, or if you're as well. You know what I mean? It depends on what latitude you're at. Well, when I saw Bob, the science guy, he posted up a picture. The only photograph he had, because he only had diagrams and other than that. The only photograph he had that he said was from he said, I don't know, I didn't get to see the photograph, but he said it was from the south. And you see the southern loop is fairly big, but you are closer to the southern loop, so it's going to look a bit bigger. It looks kind of big, but it's stretched off into the northern loop, which was way off into the distance. I don't know if it was a real photograph or not. I tried to find photographs of the southern the Analemma from the southern hemisphere and from the equator, and I couldn't find any.
The only one is from Australia. Yeah, that's the one.
Is that the same one as Bob had?
Yes, and it's during late hours of the day or early hours of the day. It's not.
It's not perfect. Yeah.
So let's ignore the southern hemisphere observations because we don't have that, or we don't have much of it. But even for from the equator and up the way to the north, the farther you go to the north, the bigger the smaller loop is going to appear. And hold on, there's something else. This Analemma is projected on a chart with specific numbers, and people use it to define the solar noon or use it for navigation. So it cannot change. It shouldn't change. And if you move your distance, you change your distance from that shape in the sky. Due to perspective, it's going to change, and all the numbers are going to be wrong.
But the flat Earth explanation doesn't change anything that the sun, it doesn't change any of the sun data. The sun's data is the sun's data.
No, I'm
The
talking
only,
of observations, not data. Only
uh,
observations. And these observations, when you overlay
well,
it on a chart, they are identical.
are you saying that it shouldn't change? What is your point about the flat Earth, though? I'm not understanding what the point you're making concerning the viewing of the Analemma on the flat Earth and what should or shouldn't change.
Yes, my point is because the Analemma is of the flat Earth is close due to the motion of the sun around the Earth every solar day along the year. When you change your distance from any object, that object is going to change its shape and dimension in your eyes due to perspective.
Yeah, well, it did. I mean, it's from the southern hemisphere. The Analemma looks a bit. The way you look at it looks different than from the north. But I mean, it is like the flat Earth doesn't have a different Analemma. It is the Analemma. That is it.
Well, it shouldn't, but reality, if you try to observe it, I mean, reality, we observe it the same, but on a flat Earth, it will not look the same.
Why? How do you know that? Why do you say that?
Because perspective.
But sure, what do you mean, though? I don't understand the point you're making.
Okay, if you have any painting on the wall that have two loops, like the Analemma, if you are standing closer to one loop, it will always look bigger than the other loop. And
so what you're saying is that we should have a much huger loop in the sky in the south than we do in the north.
Yes.
But the way it looks is the way it looks. It shouldn't look any different. It shouldn't be that much of a difference. Because, I mean, the photograph from Australia that you're saying is a real photograph that Bob showed, I don't know, I didn't see it, but what you're saying it's a real one from Australia. That is what you would expect to see on a flat Earth. I don't see the problem with that. I wouldn't expect to see anything else.
No,
you see, you can't calculate a distance to the sun on the flat Earth because we don't know what distance the sun is. Or what size it is.
But you give specifications, not specifications in numbers, but you say the locations above the equator, above the Capricorn, above Cancers, and those are translated in numbers in terms of distance. So
yeah,
if you're
the data doesn't change. It is what it is. Whatever the data says is exactly where the sun should be.
Yeah, it shouldn't, and our observation says that it does not change in shape. But when we look in the flat Earth model, an observer on the North Pole is not as close to the smaller loop as an observer, say, in London. So the observer in London will see the smaller loop way bigger than an observer on the North Pole.
We don't know we don't know. It's like that comes down to distance to the sun. We don't know what distance and size the sun is.
We know that. We know the horizontal distance at least, because it moves about the tropics, and we know the distance between the tropics.
Yes, but we don't know the size and distance of the sun. That's the difference.
We don't know the size. We can say that we're not sure of the altitude of the sun on a flat Earth, but still there's a distance that you cover horizontally that should, on a flat Earth, change the shape of the Analemma.
I have to disagree with that. I don't see why the shape would change any more than it shows in the photographs. To me, it wouldn't. To me, it doesn't.
I showed you the picture. I showed you the two pictures I took of.
I didn't see that. Which two pictures? Would you put them back up? Because I didn't see those photographs earlier. Oh. I was looking at it, but they didn't. So put them up just in case. Unless you show us two photographs, please.
Yeah, Ranty will have to do this because.
Because I think what's happening is you're making three assumptions about the flat Earth.
The Analemma S and Analemma N.
Oh, right, okay. I think N and S.png.
Analemma S, yes, PNG, and Analemma N, PNG.
Oh, right, okay. Yeah, I get you. 1 second. I'm sure you've already seen these ones.
Yeah, but I don't. Are they photographs or diagrams?
They're diagrams.
Yeah, but a diagram is not a photograph. So a diagram is pointless, for this argument, is pointless. You need a photograph. Photographs is what you need.
We have
a diagram
photographs.
won't do it.
We have photographs, but
Yeah, but there's no point in showing a diagram to show what it does look. Yeah, but this is this can't be. This is of a computer screen. It is not. It doesn't have 3D capability and distance and height and things like that. This is. I remember the one you're on about. This one, yeah. But this is not going to give it the. You can't go off of this and say, see, it should look different. The photograph of no. See, if you look at the photograph, look at the difference. When your first photograph, you're not in close to the screen like that at the northern part. You're looking at the whole lot at the northern part. Right.
I put the phone almost under the screen from both sides, and I aimed the camera to continue.
If you look at the photograph that Bob showed there, is that not very like the other photograph you have there? The loop is not as big, but it's very like it.
It just looks like all the analemmas that I see in all other
Yeah, but
places.
that's what it's supposed to look like. That's what it's supposed to look like on the flat Earth. That's what it's supposed to be.
No, that's how it's supposed to look in reality, which is we are debating now which one is which.
But it's supposed to look like it does. That's my point. It's supposed to look like the way that it looks. That's the point I'm making. It shouldn't. It doesn't have to change for flat Earth. That is what it is. My point is that is what it is. Flat Earth's point is that is what it is.
Okay, I think I'm done with this point.
I have a question for you. In your model, the sun rays are all parallel, but yet we never see this in reality. Now, Rumpus gave an explanation that it's got to do with the angular sizes of the sun, and that's why the rays are all at angles.
Yes.
Right? But we don't see parallel rays. We see angled rays from the sun all the time. There's never been a photograph of parallel rays from the sun. So how do you explain the parallel rays? Because the whole tilt explanation, it basically lives on parallel rays, which we do not see.
Yes.
So how do you explain? We don't have parallel rays. So how do you explain the seasons on the globe without parallel rays?
Okay. So from a single point on the sun, the light that comes through that long distance, let's say to the North Pole and to the South Pole, the angle between, can you imagine a triangle now that the tip of it is a point, single point on the sun, and the base of it is the distance between the North and the South, and the length of this triangle is the distance to the sun. Can you imagine how small that angle?
Yes, but that's coming from, yeah, but
yeah,
that all comes back to how the distance to the sun is measured. Then they're using that based off of basically the distance to the sun is an assumption. So
okay.
you know,
No. It's not assumption. It's conclusion. And
no, it's assumption. It's assumption because they had to assume a distance to Venus.
When you say
they had to assume a distance to Venus. There was a lot of assumptions made before they ever made a distance to the sun calculation. If you made a distance to the sun calculation and a distance to the supposed planet's calculations of a flat Earth, it's a different calculation.
Yes, and maybe that's why they change it. Because they assume something, they base on it, and it changes. But in both ways.
They made the distance, every distance to every supposed planet and to the sun and the moon all comes from a preassumption that the two angles are being taken on a globe, which changes the distance and calculation completely to what it would be on a flat Earth. So that still doesn't, but either way, even that doesn't still change the fact we do have angled rays and not parallel rays. We don't see parallel rays ever at any day ever in the Earth's history has there been parallel rays.
Oh,
so
no, you can just you'll need to provide like something, and not corpuscular rays, because I've seen flat earthers debunk the idea of the corpuscular rays. But if there's a
go on, sorry.
Yeah, what I mean by that, a photograph from an airplane at a building and showing the shadow, maybe like around sunset, showing the shadow, sorry, extending, and measuring that width of the shadow and measuring the width of the building, they are going to be the same. And the sun could be, I did some calculations, the sun could be even 2 million kilometers only, and the globe would work. So once it's upon more than 2 billions, the angle between the rays, they are very tiny. We cannot measure it with our our personal tools.
Well, I had many photographs earlier, and I can't present them now because we were supposed to go through Skype. I would have been able to present them through that, but I can't present them through Facebook. I had a load of stuff there to further debate.
Try to describe one of them.
Basically, I had different photographs of the sun doing different things. But one of the things I had several photographs of the sun rays with and without clouds, showing the best ones were actually the best ones. Well, they worked good either way, but the ones where they were coming through the clouds and coming down at angles, whereas the sun is above the clouds and you can see the rays coming from the sun to the clouds and down to the water at angles, not small angles, big angles. Never were they parallel. And photographs of the sun where it seems to be surrounded by cloud. There's cloud, seems to be cloud behind where the sun is. I'm not saying directly behind the sun, but behind where the sun is, further back than where the sun is. So all that speaks to a local sun that doesn't have parallel rays. Because I don't mind whether someone's on the globe earth or flat earth side. If they're trying to tell me there's parallel rays from the sun, they'll have to show me a photograph of parallel rays, because that's not what we see. We see something that gives rays of light in all directions. Because how can a sphere give parallel rays?
Yeah, but if the light source is far away, even as close as 2 million kilometers, you will get almost parallel lines. And hold on, did you see the images of the sun in the woods and the rays coming among the trees as if the sun is between the trees? So you can use.
Yeah, I understand. I understand that when the sun, it's like a low winter sun. I see that in the winter time where I am. If you're in the woods in the low winter sun, and when it's in the southern summer, we get the low winter sun, and the sun comes through the trees. And yes, to get through the trees, there will be some straight rays, but the angle it's coming from the sun is not a load of straight rays. There's rays going. The same sun is giving rays through the trees and rays coming down through clouds at an angle. Where I live in Ireland, we get a lot of clouds. And I get a lot of clouds all during the year. Even in the summer, we get a lot of clouds and strange weather. So, like, I see the sun constantly coming through all kinds of things and going around all kinds of things, weather and other things, to get to where I would be. And yes, you will see it when it's low in the sky. You will see like a nearly direct light from the sun through the trees. But you have to understand that that's only some of the rays from the sun. They're not all coming directly through the trees. They're also going at different angles through the trees as well. To get to you, they have to nearly sideswipe some of the trees.
Well, that will lead into the sun during sunset, when it's supposed to be a lot higher than the Earth, but we still see it at a zero elevation. So
you talk about the sunset on flat Earth, or you kind of, if that's the direction you're going with, is it?
Yes, you will have to put like 15 degrees angle or 17
degrees
angle.
What about sun fade then? What about the sun fade videos? And what about sun mirage? Have you looked into any of those? What the sun mirage is? So I had some photographs I wanted to show earlier, and they were involving the sun. I had some GIFs of the sun setting and what starts happening to the sun from halfway down the bottom, from the midway point.
I'm not talking about the angular. I'm not talking about the angular size. The angular size could be
guys, you've busted through your time. I have to say.
Okay.
I have to say you've probably got an awful lot more to speak about. I have to say. You know, I mean, if you wanted to, I could perhaps give you some more time. It depends whether or not you guys actually want to stay and carry on chatting or not. But
well, I leave it up to you. I'll do it there a small while. It could be a case of we get to a point where we're both kind of, I'm stopping here and I'm stopping here. That could happen. Now, if we go on maybe another 10 minutes, and if you want, what did the chat want to do? What the audience
I'll tell you what we'll do. Do. Well, I think we'll end it for here. And what I'd like to do from both of you, I'd like to hear where you actually think what your plan was for the 5 questions that you did tonight, where you hope it led you. Did the opponent fall into your trap, so to speak, and were you able to claim a victory? So, if you want to go first, Brian, because you had the privilege of choosing to go last in the actual format.
I don't mind. You can leave Crow go first. I don't mind. I'll go.
No.
Go
ahead. You go ahead, Brian. Okay. You go first. You tell us why you think you won.
Well, I can't say that I think I definitely won. What I will say is my questions were based around what we can prove and what we can't prove. The flat Earth is a much easier thing to prove than the globe Earth, because with the globe Earth, rotation has to be proven, curve has to be proven, then gravity has to be proven. All these things have to go in, and that's just for the Earth itself. Then there's the whole travel around the sun, the offset sun, the 2 different distances of 4,800,000 kilometers. And there's kind of a hand wave dismissal goes on there concerning that by the globe side. I just believe that rather than a victory for me, I believe the flat Earth had the victory, simply because what I'm saying concerning the flat Earth makes so much more sense. It's so much more balanced and natural, and that the globe, my full belief on the globe Earth explanation of the Analemma is that it had to take the globe Earth and kind of warp it around what the sun is doing. What we see in the sky is the sun doing something, and as a flat earther, that's what I believe is happening. The sun is doing all these things. But the globe Earth explanation had to wrap itself around and warp itself around to make it so the Earth is doing all these things and the sun is stationary. So to me, the globe Earth explanation is like somebody after drinking a load of whiskey and snorting a load of cocaine and going crazy. And the flat Earth explanation is when they sober up. That would be... So rather than me trying to have a personal victory over Crow, I believe that it's a victory for flat Earth over the globe. As far as the Analemma is concerned, I believe that the Analemma, for my personal belief, is the Analemma totally proves flat Earth, and this proves the globe. As the globe has to get too complicated to even get to the point of proving the Analemma, the globe has to prove a load of other stuff. Whereas the flat Earth just has to prove that the sun is doing what it's doing. And all the data is there for that. So that would be. Now it's up to the chat. It's up to them who they feel come out on top.
Crowexe, would you like to give your response to why you actually think your questions led somewhere, and why you think that you actually ended up winning this debate as well?
Okay, so my questions were in 3 categories. The first one is to make sure that we are on the same page on certain things. That's the question 1 and 2 and 2A. And the remaining 3 questions was just to show that, and to be honest, I steal that concept from Brian. He inspired me when he said back engineered. So my questions was revolving around this issue that we back engineered our observations into analysis, and the analysis came up with some crazy things, like there's something called gravity, there's something called huge distances. These were the conclusions, as much as they sound crazy, but they are still conclusions that when we reverse engineer these informations, we can predict observations that we see in reality, and it explains observations that comes from reality. The third section was just to show the impossibility of some observations on the Earth if the Earth was indeed flat, which is the two questions about the analemma for perspective and the speed of the sun when observed from opposite locations. Especially the speed of the sun. That question I didn't. The answer was so far away from anything that could explain it to me, because I know that if the sun is taking a smaller circle, then someone on the Capricorn is going to see it moving slow, and if it's on the Capricorn, the sun is moving faster, then this should be observed that the sun is moving faster. And what we do with this, to inspect this, you go to time and date for any of these locations that I mentioned, and you move the slider until it's noon, and then you just count 5 minutes on the sliders. You know the time and date, it has a slider to show you the sun elevation and the sun azimuth. So if you move that slider 5 minutes before or after solar noon, you will see a change in the azimuth. That change should be equal or not should be equal. It is equal if you go to time and date, but on the flat Earth it doesn't happen this way. So the explanations are, as I say, they are more of descriptions of why the sun is doing this because it's doing this, while my explanation is reverse engineering of the observations, shows that the sun is doing certain things and the Earth is moving in a certain way, which is, no matter how it sounds crazy, but it describes the reality that we see.
Could I say one thing there, Randy?
Yeah, if you allow Crow to say one thing afterwards, yeah.
Yeah, sure, but yeah. Crow, in your model, in your explanation on the globe side of the Analemma, the only reason that the Earth moves fast in the southern hemisphere and slow in the northern hemisphere summers, respective summers, is because of the sun's movements in the sky, faster in the southern hemisphere summer and slower in the northern hemisphere summer. If you don't believe or you don't agree that the sun changes speeds throughout the year, and you believe the Earth is changing speeds throughout, let's just say you don't believe the sun is changing speeds throughout the year, and that ends the flat Earth explanation of the Analemma, but you believe the Earth is changing speeds throughout the year, then you have to ask yourself, how could the Earth be changing speeds throughout the year when all the data for the Analemma comes from watching the sun? So if you're saying that the flat Earth, that the sun is not changing speeds throughout the year, then that absolutely debunks both explanations. Both explanations are out the window.
What do you say?
Because if you look into it, sorry, 1 second. If you look into it, you're told that the Earth is moving faster at one time of year and slower at another time of year. The only reason that they came to that conclusion is because they are twisting the Analemma, they're twisting the globe model around the Analemma. But the only way for that to be part of the Analemma is because the sun is moving faster in the southern hemisphere sky and slower in the northern hemisphere sky. Summers. I even have something here. There's something here I could even. I'm not there. I think I have it here. 1 second. Supposedly, we're moving faster. The Earth, the globe Earth, is moving 67,777 miles per hour in this southern summer, and 65,520 miles per hour in the northern summer. That's 2,500 miles per hour of a difference. Why would it be doing that?
Can we work with ratios?
If the sun is not
1.034, 1.034 faster, because I cannot memorize numbers in my head. Do you agree on that ratio?
1.034 faster of the sun.
1.
In miles per hour.
Yes.
In miles per hour. What's more? And see, this is what we're told. But if the speeds of the sun is not matching the Analemma explanation of the globe, then the Analemma explanation is wrong.
No, the change of
that. There's no way out of it, because everything
Could
the
you
global
let him
Analemma
respond there,
explanation.
Brian?
Sorry?
Could you let him respond? You've took 5 minutes to ask
Oh,
this
sorry.
question.
Yeah.
Yes, the change of the speed. I'm not sure how they detected it or who's the first one to notice it. Maybe Kepler, maybe someone before him. But anyway,
What did they study? Well, hang on 1 second, Crow. What did they study to get the data? What data did they come up? What were they studying? The sun.
The sun movement. Yes.
Yeah. So if the sun is not moving faster, then why would the Earth be moving faster if we're going around the sun?
Okay.
If the sun is not moving slower, why would it be moving slower?
If you could let Crow answer, that would be great.
Oh, sorry.
First of all, the ratio of the sun speed for the globe is very way less than the ratio of change speed for the flat Earth.
How do you know for definite that that's the speed and what's that in miles per hour? How do you know for definite that that's not happening? Because if it's not happening, both explanations are wrong, bro. Both explanations have to be wrong.
No. When I talk about speed, I'm talking about the angular speed. I don't care for the distance of the sun. It could be 2 millions. It could be 2 billions.
Yeah, but see, you have to understand. In the flat Earth model, in the flat Earth explanation, right? In the southern hemisphere summer, the sun is lower in the sky. Okay, so your angle to it is different. If you're measuring speeds with the sun always the same distance away, then it's not going to be a correct speed calculation because the angle is not going to change. As in, the point I'm making is the sun is lower in the sky in the southern hemisphere summer. And if you're saying that the sun is not moving faster through that summer, then if you're saying that that's not happening and the sun is not moving slower in the northern hemisphere summer, then both explanations for the Analemma are wrong, and this whole thing was a waste of time, because if one is wrong in that way, then the other is wrong.
Okay, so
if the sun is wrong,
Brian,
if the sun is, sorry, yeah.
Brian,
that's what I finished.
so
if the sun is not doing...
Yeah, you've had yours say now. It's 12:30, so I'm going to let Crow answer your thing, and then we'll round up. Okay, so Crow.
Yes, I was hoping you were ready with a number, because I had the number before, but I forgot it. The ratio of the speed of the sun on a flat Earth during summer and during winter, the ratio is way higher than 1.034. So it's not the same ratio.
What do you mean on a flat Earth? Who calculated it on the flat Earth?
Okay, because the distance to the equator from the North Pole is confirmed on a flat Earth. That is around 10,000 kilometers. And if you calculate the radius, this as the radius of a circle, so this circle is covered in 24 hours when it's on the Capricorn, and the same thing when it's on the Cancer. So
you're saying that the sun is not...
Okie dokie. Right. Well, we've heard the debate there. I hope you guys enjoyed it. It was quite a long one. What are we doing now? We're doing 2.5 hours. 2.5 hours on this one. But yeah, I mean, these guys were very civil. They chatted really well. That's all I can say. There was no swear words. Not a single swear word. There wasn't a single claim that a question hadn't been answered. So yeah, it's just happy days. Right. So I'm not sure when the next round table will be back. It will be back next week at some point. It could well be Monday. If not, it's more likely to be Wednesday, but we shall see. In the meantime, over here, I'll point you over again. Which arm is it? The round table. There we go. Here we go. Patreon. Become a Patreon. There we go. So if you want to become a Patreon to the round table, we have 110 watching right now. I would hope that at least one of you have been entertained during the time that I've been doing this. This is probably week 6 now, and we're clearly up to well over 20 different presentations and the like. And there's all kinds of different tiers here that you can join. I would appreciate your support over here. It will allow me to essentially spend a little bit of time doing this, because at the minute I am essentially worn out. I'm with all the work that I do as a decorator and looking after my mum, I don't get any time for myself. I put all my spare time into this project. So essentially, in order for me to carry on doing this, I need to cut down my hours slightly at work, which will give me a little bit of me time to carry on the round table for you guys, essentially for you guys. So the ball's in your court. If you want to support the round table, I'll be very much appreciated. I'll post the link right now. 110 people watching, or as people run off now that I'm talking about this Patreon, more than likely. Right, so there's the Patreon link, and yeah, hopefully I will see you very soon. In the meantime, take care, have a good night, and see you next week.